I'm Patrick O'Neill on the floor of RSA with Jay Kaplan from SYNAC. SYNAC is probably widely most famous for the Pentagon bug bounty program, which had some widely covered results last year, but obviously there's been a transition in government that you might have heard about. So I want you to tell me what the forecast is moving forward with the new DoD, the new White House, and everything else going on. Are the bug bounty programs going to continue, and what's going to change?
Yeah, thanks. It's great to be here. So I think one of the big reasons we're famous for I guess, the DoD and some other work across the government is because we can actually talk about it. We're doing a ton of work across, private enterprises, big banks, big healthcare corporations, big technology companies. But finally, since the government has to say what they're doing in the cybersecurity arena, and because this is a public solicitation, it's out in the public sphere. But I think in the case of DoD, regardless of the fact that we have a change in administration, this is still a wildly successful program. We just wrapped up our first project with the Defense Department focused on a highly sensitive internal asset. This is the first time they've launched any type of crowdsourced security model in the more in the internally facing side of the network. It was something that was widely deployed across the organization, and we had tremendous success with our model in finding some very serious flaws, and ended up on the Secretary of Defense's desk very, very quickly within a 24-hour period. 80 researchers engaged, lots of money paid out, and I think this has set the precedent moving forward. So we're looking forward to working across the DoD on a number of other applications and across the federal government as a whole. We have a lot of ongoing discussions with civilian agencies as well.
So you said 80 researchers engaged. Are there any other specifics you can talk about as far as results, as far as number of bugs, number of critical bugs, and the specific amount of money?
Yeah, so a lot of the details, being that it's more of a private type of program, we have to keep close hold. But we can say one of the largest payouts was over $30,000. 80 researchers were engaged, multiple high severity vulnerabilities were found. We accomplished kind of the mission at hand. Really, this was a mission focused objective, so we basically had to break something in a certain way, and we were successful at doing that. This is an asset that was tested rigorously by a number of contracting organizations, a number of integrators, and ultimately we've proven that the crowdsourced methodology really works.
Who are the researchers? How do you get them? How do they get cleared?
Yeah, so in this particular situation, we were focused on researchers from the United States as well as Five Eyes allied nations. So, we're talking about the UK, Australia, New Zealand, and Canada.
Don't forget our Canadian friends.
Of course,
Jeez.
Right? So basically the process was that they had to prove they were a citizen of one of these countries, so we basically do passport verification of that person. We do background screening, so we handle that whole process. So we check for criminal activity and so forth. We then have them sign non-disclosure agreements and other contractual obligations, and then finally we enable them to participate with us after they go through an actual skills assessment. That's another final piece of the puzzle. They actually have to meet a minimum bar of skills before we enable them to look at our customers' environment. So it's a much more rigorous process that researchers have to go through than a typical open bug bounty model, but we find that extra control lends to better results overall, less noise, and really helps us achieve the objectives at hand.
All right, well, let's talk about lessons learned. What are you seeing as far as lessons learned on government side, but also from you? What are you seeing that you did wrong that maybe you can fix the next time around?
Yeah, I think I wouldn't necessarily say it was something we did wrong, but what we did learn is, in the inside of a government network, given that we had to replicate that network in its entirety in almost a lab or a range environment, it certainly made the task much more complex than what we're used to. When we deal with large enterprises, we're typically testing against production, and so that is the real environment, and when we find something in that environment, we know it's legitimate. In this case, the government had to basically say, okay, this is what it looks like in practice, seeing that it touches some classified infrastructure. We couldn't test against that directly. And so we had to basically put it in a lab, make sure that lab was working. We had a VPN researchers into that lab environment, which added some additional complexity. And of course, we have to log their activity, so for auditability. So there's a lot of moving parts and a lot of things we had to figure out. Our engineering team did a fantastic job at really bringing all the pieces together, but it took a lot of time, right? And so, that was obviously a learning experience for us, and I think will help us moving forward as we move into further objectives.
So it sounds like versus bug bounty in the private sector, there's added complexity, added controls, a lot of rules and things that you have to do that you wouldn't otherwise have to do. Does that impact the results in any way?
I don't think it does. I think, while there's additional process, and even additional process for the researchers to go through, whether that's from the vetting side or from the actual technical implementation of setting up their machines so they can connect in, they don't mind doing it because it's a really exciting project. They want to be part of it. The money is really good on the other end if they're able to find something. And so I don't think in the end that it really impacted our results at all.
All right, great. I'm Patrick O'Neill. Thank you so much to Jay Kaplan. And this is RSA. Thanks for watching.